Okay, let's officially get started again. Day 2, Object-Oriented Programming in Java. Continuation from day 1. Let's see, nothing else has changed outside of the day. Still looking at object-oriented design in Java. What I'm going to do right now is go over assignment number 1. And then we'll lecture a little bit more, and then I'll go over assignment number 2. We'll lecture a little bit more, and I'll let you guys go. So that'll probably take up most of the day, though. Hello. Welcome back. Alright, so let's orient ourselves to assignment number 1. So we're going to write a temperature class that has 2 fields. It's going to be temperature. It's going to be a float number, perhaps, and a character. And the character is going to be in Celsius or Fahrenheit. And we're going to make sure that these 2 classes can only be accessed through an accessor method or modifier. Message outside of the class. So that paragraph is kind of loaded, but we're going to start with the first paragraph. So we know what this only accessed through accessor methods means, right? From yesterday I talked about accessors and modifiers and a way to set and get information that is stored by a class. So I purposely put this in here so that you make the temperature values for the value of the temperature and also for the type, Celsius or Fahrenheit, make them private. That's what this means. Okay, so we're going to say, well, let's do this in Eclipse. So pull up Eclipse. And I'm not going to do the whole class for you. I'm just going to get you started. And it serves a couple different purposes. The first one is it provides a little review of what we talked about yesterday. And the second one is it kind of gets you started on the first assignment, so students don't wait till like the middle of the course to start doing the first assignment. Because after this class, you can do the first assignment, the second assignment as well. So. And let's see what I got going on here. Actually, I have an assignment number 1 up here. What is this one? We'll just play around with this for a second. I am going to go into Eclipse, which is what I've done right now. For those of you who just walked in, we're doing assignment number 1. Not going to do the whole thing. I'm just going to get you started. I'm going to go File. We could create a brand new if we wanted to. We could create a brand new. Let's do that. Let's create a brand new project. Let's be good about this. New Java project, and hopefully that's what your menu looks like. And I'm going to say. What was that called? Temperature? Temperature. Hopefully I spelled it right. I'm going to call it project temperature. And I'm going to leave everything on the defaults. Zoom out a little bit so I can see this. And I'm going to go say finish. In future classes, you can kind of look at this stuff and you can play around with the options, but unless you know what a jar file is, unless you know what some of the other stuff is, it doesn't really help you very much. So now I have a new project called temperature, and I have the source directory, which is empty, and I have the JRE system, which is you're gonna leave this on the default as well. I selected 1.6 for the JRE. This is gonna be my Java runtime environment, which is showing me all my class options and things, and they're all jar files, by the way. And the jar file is sort of like the zip file of Windows. Well, actually, jar works in Windows as well, but it's kind of a compressed file of libraries. So all of the library files are in a jar file. You don't actually have to unpack the file. You just leave it alone. So a lot of times when you install things like JDBC drivers and stuff like that, you're downloading a jar file, and they're telling you, oh, put the jar file in the Java bin directory. And you're like, okay. And you're like, well, how did I install anything? It's like, well, you don't have to. The program just calls in, and it's kind of like the packages. Everything is compressed in there. It's the object code that gets bound in when you compile. So the JVM knows about the jar files. It's really all you need to know. So you don't really ever have to touch this. If you start messing around with this directory, and then you end up with problems. And then you just rebuild your project if that's the case. Just don't go into that directory and it'll be fine. Okay, so we're going to create a new class. And we're going to call the class, so well, let's create the new class here. So I'm in here, I'm going to go new. We know about packages. We could create a new package if we want. I just put it in the default package. I'm not going to bother with that. I'll done with that in the future. And interface, enumeration. No, we don't want any of this stuff here. I'm just going to want class. So I'm going to create the second object, sure, class, which is about as far as we've gotten. And if I created a package here, let me create a package actually. Or no? No, let's not create a package. Getting too carried away here. We'll go simple right now. I'm going to call this class temperature, because that's the name of our project. Hello, that we are creating. And modifier. So you know the word modifier right now, right? Hopefully, access modifiers. It's going to be public, default, private. We're going to go public. We also, and here's our abstract and our final. If you remember this from yesterday, all of the options are actually clickable, which is why I like this Eclipse interface. You don't have to think; it does it for you. Do we want a superclass? Well, we're going to look at that. We're going to look at this later. In fact, that's the first lecture I'm going to go over. In inherit abstract methods, and you don't even have to check that, actually. You could just leave it like that if you wanted to. Or we could leave the checked constructors from superclasses. Public. This is all going to be inheritance stuff we're going to go over today. I'm just going to press finish because I just want the class. And so now if I go in here, I say temperature. And if I come up to the top, I get the template for the class, which is public class temperature. So let me go back to my instructions, because I'm learning how to program in Java, and I'm going to write my first class, and here it is. So I write a temperature. And notice there's a capital T, so it's nice capitalizing in my review as well from yesterday. So temperature class has two fields. Fields are data members or members. So we're going to create two fields. Temperature value, which is going to be a floating point number, and the character, which is going to be Celsius or Fahrenheit. So it said to make sure that these two fields can only be accessed through the access methods. So I'm going to go back to Eclipse. And I'm going to say float. Oh, what did I say? What was it? Temperature. Temp. Let's call it temp. Float temp. And I'm going to go semicolon. And just if you're brand new to programming, a semicolon at the end of each line terminates the line. And of course, you need to know a little bit more than that at this point if you're brand new. Let's say character. I don't know what we're going to call our character. Type? T? Let's go T. I like T for type. But the instructions say this is actually legal. But I haven't put any access types. I didn't say public float, private float. And the instruction said make it private. So I'm going to add the word private here. Let's say private. I'm going to come down here and say private. Ooh. And you notice I'm starting to get these little error messages that pop up. It's just warning messages. Warning messages are going to say, it's never used. Of course it's not used. I haven't done anything with it yet. So, and here's the other thing too. So when you start writing this, it's easy to take source code examples, cut and paste them, and start modifying it. But when you start writing it, then you realize, oh, there's some rules. You want to make sure that you just noticed a few minutes ago probably I put some spaces in here. I want to make sure I put everything inside of the class. It's not like C++ where you have a function ends, another function ends, another function ends. Main's over here and it's separated from. In our class, we want to put everything enclose it inside of these open and closing brackets. Sometimes when you go and because I've done this myself actually. You're up like this and there's no space over here. I have a tendency to come down here and go, okay, so temperature. I start writing the methods and it's outside of the class body. So that's why I kind of just do this. Just put some spaces in there. All right, so we've actually accomplished the first paragraph so far. And that first paragraph was to give us two variables, two data members. And yesterday I talked about constructors. So here's a little review of the constructor as well. Constructor has the class, our class temperature, and so far we're just working with class. Should have 4 constructors, one for each one of the instance fields. Because we got 2. We have a temperature and a type. So we want to create 4. Assume 0 degrees if no value is specified, and Celsius if no scale is specified. This is an interesting kind of statement. This means this is the default constructor, and we're going to have 0 and Celsius as the default. So I'm going to go back out here, and I'm going to say, well, I have to create a constructor. Constructor is going to be void. It's not going to return a value. We always have to put a data type. And we're writing a method just like any other function or something. So I'm going to go void temperature. it's going to go, what happened? Oh. And then you notice as I type this, I actually kind of find this a little bit irritating sometimes. All this, red stuff, like, just looked over. So I'm going to make it a little bigger so you can read it for those of you. And if you're doing this, pull up your computer and start doing assignment number 1. Copy this. You can turn this in. That's what I'm saying. So you don't have to like do it your own later. Bring it up. Do it right now. Get it over with. This one is not going to take on any parameters, and the syntax is exactly like C++ and C, opening and closing brackets, opening and closing. There's nothing in here, kind of thing. We could theoretically, I could put here, and I could go public. I can make it public void. Be more standard. If you don't put anything on there, it kind of, it says you don't either know about it, or you're sloppy, or I don't know. So I'm going to just leave it alone. And if you notice another thing here that's kind of interesting is that Eclipse Browser will automate stuff for you. For example, when I put this opening bracket in, it put the closing one in there for me. So you kind of have to get used to, and every time I go, because sometimes I do this in Notepad or something else, and then I get used to the, wait a minute, and then I got to put it in manually. Then I start noticing what Eclipse is doing for me. So, and again, you don't have to correct these, but if you go over here, it'll say change to constructor. Oh, okay. Well, there we go. Now I got the constructor, but it took out the void because it said, well, this is a constructor. It identified it as a constructor because it had the same name. So by default, they are void. So it will actually work it'll work just fine like this. So in fact, it's standard not to see the data type because it's unnecessary associated with constructors. So before, when I had it, it didn't give me an error message at all. But when I looked at the warning that was up here, it said, hey, you know what? This looks like a constructor. And I clicked on that little option. It turned it into a constructor for me. So that's another example of some of the things you can do with Eclipse that might help you a little bit. So, and don't worry about it. I'm not going to do this all day. I'm going to go a lot slow right now and show you a lot of programming stuff. And then we're going to zip through examples that are already written. So you don't have to. For those of you who don't have a computer, you don't have to sit here and go, oh my God, I don't have a computer. What am I doing? I'm not writing all this stuff down. Or I could write it down. Who knows? All right, so let's go back to the constructor. We want to set, I'm going to call this type actually because I don't like T, it's too small. Type, there we go. We're going to set the temperature and we're going to set the type. So type is supposed to be Celsius, temperature is supposed to be 0. So I'm going to go temp is equal to 0. And I'm going to go type is equal to C. So I got the opening and closing. If you notice when I did the opening, it put the closing in there for me. And then it put my positioned me. You see there's like a little, oops, no, there was a line that goes here. There's a positioning thing that happens. So let me do that again real slow so you can see. I put the first one in. See that green line? It kind of ends up right here. And then it cursors you. And it's just kind of nice. So I'm going to make that C. And then all I have to do is arrow to the right. It takes me back, and I just put that semicolon in. And then I can go, well, okay, this is kind of sloppy, but I'm not doing inheritance. The other thing I could possibly do if I wanted to is go like this and say this dot temp. And then I go, oh, this is the first time now we're seeing this pop-up window. So when I say this, it's going to give me, well, give me everything that's this. We only have 2 thises. And this means it's inside of the class. It's this temperature objects class. Excuse me, objects method. Excuse me, data member. Get this right. It's early in the morning for me. I guess I haven't woken up yet. So we have other methods that we could run as well. Every time you start using the dot for the methods, the screen is going to pop up. Some people don't like the screen. You can turn it off. You can change the settings to turn it off. I just leave everything on the default so you can see what happens. Alright, so I could put the this in. You don't have to put the this in. But I do that by practice only because then I know it's in here. And when I do inheritance, which we're going to talk about today, you'll see, oh, it's the temperature, not the extended temperature, but this one. So, alright, let's go back to the assignment. We are good students and we're following through our instructions properly. Okay, we put the default constructor in there. We need 4 of them. We also want one with 2 parameters for the instance variables and a default constructor to set, well, it's kind of redundant, to set the 0 degrees to Celsius. Well, we just did that. So now we need one for each one of the separate ones and one that does both. That's what this is saying. So that's 4 total. And I could do this. Oops, I don't want that one. I want this one. I could do this quite quickly, actually. So I'll just put them in. In fact, I'll just put, you know what, I'll just make one more. How's that? Public. And I'm going, I'm spelling it wrong. Oh well, temperature. Oh, she brought her book. Good. Got Java and everything on there? Start typing. Start doing a typing number 1. You can turn it in by the end, of course. I mean, by the end of today. So, all right, so then I'm going to put parameters in here. I'm going to put in here float f. And then I'm going to say character t. Because I like to. And this is kind of an interesting thing that a lot of people used to do that they don't do very much anymore. Another kind of standard programming practice. You put like one single character in here. And you make these, that's why I kind of changed type. You make these like full names, but you put single characters in there. I think it's just easy, because these are temp. You know, they're not going to be used very much. You know, they're just taking in information. And then here I can go this dot type is going to be equal to f, no, to t. And this, it doesn't, I guess the order doesn't really matter, but this dot, let's say temp is equal to, and if I arrow down, if you saw what I just did a second ago, I started typing in and the screen comes up, and I can go, well, what do I want? A temp. Helps my typing. It's equal to C. And, it's not C, it's T, wait a minute, T. I'm already messing this up. F, there we go. Here's another interesting thing as well. When you click on it, you see this T over here started, got highlighted. If I click over here for this temp, you see all these temps get highlighted. It kind of helps you with your logic as well when you're thinking about this and you're going, well, temp, what is this temp? Temp, oh, here's temp. Temp's supposed to be 0. Ooh, wait a minute, I got this backwards. The temp is F. And then I can go, oh, let me correct this. I have this backwards. So temp is supposed to be F. And type is supposed to be C, or T for type. And I go, oh, now I have it correct. Because you can check your data types a little bit. You can check, where's type? Type is up here. All you have to do is click on the name of the variable, and it just highlights all of the other instances that the variable is being used. So it's kind of helpful that way. All right, that is one constructor. And then as an example, I can go, I'll just make one more. You have to make 4 of them. I'm going to make 3 of them. 3 of the 4. It's not a bad deal. I'm just going to go character T. And notice I can reuse these characters. What's wrong with you? I probably misspelled it. So I hovered it over. Set method type to void. No, change to constructor. Change to constructor. There we go. So I misspelled temperature. So my typing's not so good. So this one's just going to say this dot temp. Oh, what did I say? T for type. Type is going to be equal to T semicolon. There we go. So notice inside here I didn't say character type is equal to, you know, I didn't redefine. I'm using these variables inside of the methods. So we're almost done with the second paragraph. So let's go back here for a second. Revisit the instructions. Oops. And try if I can figure out how to make this smaller. There we go. So that's what I was trying to do. Okay, let's see. Oh, I accidentally, maybe I can do an undo. Hold on a second. I guess we don't need it because it's, oh, there we go. All right. Methods. You might be wondering, well, we just created methods. Yeah, we're creating more methods. Constructors are methods. So the class should have 3 types of methods. And this is where I'm going to let you finish some of this stuff. I'm not going to do this whole thing. So the class should have 3 types of methods. The first one, we want 2 methods to return the temperature. One to return the degrees in Celsius, the other to return the degrees in Fahrenheit. Okay. And use the 2 following formulas to write the 2 methods. And you're going to write the methods. I'm just going to return this stuff for you. And you can actually return it in a couple different ways, and I'll show you in a few minutes what you can do with that. You're going to have 3 methods to set the fields: one to set the value, and one to get the scale, and one to set both. So those are the sets and the gets. This is to change the temperature from one to the other. This is the sets and the gets. Let's do the sets and the gets. I'll do a pair, and I'll just do one to set the Celsius. And then you're going to have one that's going to compare. You're going to a comparison method of the 2 parameters. Both of the 2 parameters are objects. You don't know compare yet, and we're going to look at compare today. So I'm going to skip that one as well. And you're going to put that in there. And it might be different scales. One might be a temperature in Celsius, one might be a temperature in Fahrenheit. This method should return the integer, and then you can read through here: 0, a 1, or a negative 1, depending upon whether it's equal, less than, or greater than. In terms of means the temperature is higher or lower than the other one temperature. So you're comparing one temperature with another. So let's do 2 sets and gets, and then the last part of it is the driver program. You're going to you also need to write a driver program that tests all the methods. So we're going to write a driver class, which contains a method name, main method, I should say. Make sure to use each of the constructors and methods, and exercise all the stuff. And design the driver program in a way that when you run the program, you don't have to provide. So it's not asking for command line interface. If you want to add command line interface to it, you can, but just make it so you can hard set. Just run through all of the methods and exercise the classes. And here are the instructions for if you wanted to. So if you don't provide any of the parameters at the command line, you're supposed to have it automatically set. However, the instructions are telling you to put the command line stuff in, and I'm telling you don't have to. So what I'm saying is not in the instructions. So just as a side note. And then, but this might be a good practice for you if you wanted to. If you're using Eclipse, it's kind of hard to put the command line arguments in there. You have to go back out to a terminal window or a DOS window to actually type it. You guys are familiar with the concept of command line arguments, I hope. It's just stuff you type in after the name of the file when you run it. Went over that yesterday. Okay, good. And here's a hint. I can get the command line. Let's see. Command line from line are all strings. You parse it, convert it to that array. But you don't have to do it if you don't want to. Let's see. Submit your Java code. Yeah, I just need to see the .java files. I don't need to see. And you're going to have 2 .java files. I don't need to see the project, but if you have it in a project, you can zip the project and send me the project. Or you can just zip the 2 files together if you're not using Eclipse. Which is pretty much the end of assignment number 1. So let's go out and I'll write a couple accessor methods. We'll write the driver, and then see it run, essentially. So now I'm going to write another class. Make this a little bigger. And it's going to be, let's do a void one to set temp. And this is kind of like what I sort of like to do in terms of organization. And then I can go down here and go void, get, void. Get temp. And notice I haven't filled in all this stuff yet. I'm just kind of making a list of all the ones I want to create and all the ones I want to do. And then after I have all my, change temp, I can just leave it empty and then I can come back in and fill it in. So I know I want, a couple more. I'm not going to put them in there. I'm just going to get a set and a get. So the set temp, to set the temperature, I'm probably going to want to take a temperature in. And the temperature I'm going to take in is going to be, let's see, what do I want? I want to set the temperature, so it's going to be a float here, so I'm going to go float T again. Oh, that's type. That's my problem. Float is my F here. I probably should have said this because they both start with a T. That's my issue. Okay, it's okay. I can use T for that, or actually I'll just go F. There we go. And then get it. It's not going to do anything. It's not going to take on any parameters because get's going to print something to the screen. It's going to show me something. set is gonna gonna set it for me. So this one here is just like the constructor. It's just gonna be this dot temp is gonna be equal to f. So, and I could I could print something to the screen if I wanted to, like system.out.println. Oops. Print line's actually in here. It is print. You can see all of the different prints that we have here. Let's see, print line. It worked. Temperature set. How's it? Temperature set to temp. No, I'm not going to do that. I'm just going to go temperature set. I haven't showed you strings yet, so let's just do that. And then down here, I'm going to say get. Well, this could just be float actually, because we're going to return something. So float get temperature, and why do I have an error here? Add return type. Add return statement. Ah, okay. So this is another interesting thing. It said I changed it. It was void. I changed it to float. And so I'm like, well, why is that underlined? So don't be afraid when you see stuff underlined. It's not necessarily that you've made an error. It's that it noticed I changed the data type instead of void, and now it wants me to put in it doesn't want me to forget the return type. So I'm going to actually add the return statement. There we go, return temp, which is what this is doing essentially. So, which was kind of good. Now I'm getting the temp, return temp. I can have one that says get the character, return the character. So kind of easy. And believe it or not, outside of doing the other one, this is going to be the comparison, but we don't know how to do object comparisons yet. We're going to learn that today. Outside of that, we're pretty done with this with the temperature class. Although we can't convert one to the other yet, but I'll let you figure that out. You have to write something for the assignment. So. Now we need a driver program. So, and I think he wanted us to call it driver, actually. So I'm going to go up here, and I'm going to go up here, and I'm going to say new class, because it's another class. I'm going to put it in the same project, same location. I'm going to call it driver. Drivers are actually kind of simple because they all look the same. I'm going to go finish. And I come back here, and I say, oh look, now I got the driver class. Driver is going to be our main program, and I'm going to go back over here actually to show you some other options. You can go main, my class, you can call it anything you want to call it. If you click on the typical driver program and you're not familiar with what you need to put in there, you can always either memorize the template, or you could do what I kind of do sometimes is when I get lazy. So let's just cut and paste it. Driver's going to have one main method in it, is what it's going to have. So I'm going to go down here, driver, and I'm just going to go I'm going to go, okay, this would actually run. It's not doing anything, but this is my driver program now. If you don't like to put this in here, you don't actually have to you don't even need this in here. If you go like this, take that out and say. That's for your command line arguments, though. You'll see that in most examples because it gives you the option of doing command line arguments. So out here, we only know I/O yet. We don't know any of the other methods. That's what we're going to do today. So look, expand our vocabulary a little bit, but we've learned system out though. Right? So we've got that one. But before we do anything, we've got to make some instances of this object, temperature. So I'm going to create two temperatures, and I'll run both methods, and I'll print it out to the screen, which is what you're doing in your assignment. So this is what you're doing, but you're just going to run everything. I'm going to run a couple of things. So I'm going to say temperature, which is the class that I have. I'm going to call it temp, capital temp 1. Let's do that. Temp 1. Temp 1. It's going to be equal to new temp. Oops, got the caps locks on. New temperature. And then I get my little warning. Oh, it's not being used. I know it's not being used. I just created it. So I'm going to create another one. I'm going to say temperature. Temperature. Temp 2. Oops, temp 2 is going to be equal to new. Well, let me run one of the constructors. I had one that took both. I'm going to say temperature. And the way I run the constructor, because this one would essentially be the same, is I put the two items in there. So I'm going to go, what was the first one, the value? It's like 2.0, and it was Fahrenheit. Let's do Fahrenheit. So now I have two instances, and I have a typo, because I can't type. I've got two instances of two variables. What's wrong here? Let's see. Remove argument to match temperature. No. Change constructor type. How about cast argument to float? No, actually there's a better way of doing it. Let's just do this. It didn't like it because it didn't think it was a float. So casting is kind of dangerous. I only use casting when I make one object into another. And let's just talk about objects for a second. So if I had temperature, and it's an object of temperature, is also an object of object, and there's nothing else to it because it hasn't been inherited yet. And so I can treat temperature like a temperature, and when I do that, it's what's called casting, which is what happened here a few minutes ago. If you watched it, in fact, I can just repeat it. Say, well, if I hover my mouse over, when it says cast the argument 2.0 to a float, if I select the dot option, I typecasted it. I said treat 2.0 as a float. That works just fine, but you don't really need to do typecasting here. All I have to do is I had to put the F there to convert the 2.0 to a float, because otherwise it's a double. So it was a mismatched data type, essentially, which is kind of like what you'll need to do for floats, is just put that F in there at the end. Or you can just leave it like this and say, just make this a float 2.0, convert it to a float. Because everything is an object. Variables are objects, strings are objects, and you cast it to one. If you want to use that as a float, tell me it's a float. If you want to use it as a double, tell me it's a double. Stuff like that. So when you do objects, you can treat one object as if it's an employee, you can treat it as a staff person or as an object, and you can go back. That's how you actually go through the inheritance line, because it's equal, it's equivalent. People have a bad use of typecasting because they use it as a crutch in C or C++ to mix and match variable types when they're doing addition, or they're doing some calculation on something, and they get a value that's not the same. Like they can't add an integer with a float, so they typecast the float to the integer. Causes mathematical calculation errors and stuff like that, rounding errors, all sorts of different stuff that goes on with that. And most people, you learn, oh no, that's bad, don't do that. But then when you hit Java, you go, oh no, you have to do that. It's like you have to cast objects to their different types in order to compare them, in order to use them, which is kind of like what this object type is all about that I want to talk about today. But let's just leave this alone. And now we're going to do we have two objects, so I can run a method. So I'm going to say, I think I had one to set. So I'm going to say temp1 dot set. Here it is. And I can go down here and what was that called? It was called set temp float f. Oh, okay. So I go like that. And now it wants me to put a float value in here. It gives me an option like 0, 1, 2, 3. So I was just going to say 0. Yeah. If I really want to set it to 0, now let's set it to 50. 50 years. There we go. And then I'm going to run a method to get it. So, but let me get it and put it into a system out, because when I get it, I'm not going to do anything with it. So I could do this, and this is kind of interesting. Actually, let's leave that one up here. I could go temp1 dot set temp. Well, I want to set to what temperature number 2 is set to. And in here, I can go temp2 dot get temp. And what I just did in this, oops, is a typo. What I just did here is I set temperature 1 to equal the temperature 2, and I used the get temp. So this is kind of common too, because you're getting when you get it, it's coming back out as a temp when a temp is a float, and it's not being it's not like converted to a string or anything like that. So you can take the data member of one object and add it to the data member of another object by using the get temp. You can because it kind of comes in handy, which is why a lot of people would do the get temp. Because nobody said it, but some people, when they start thinking about it over here, it's like, well, why do we want to return temp? Let's just print it to the screen. Because we could just did have done a system out, you know, print it to the screen. But that doesn't serve the purpose of the get. It's not returning any value that we can use somewhere else. And we're doing this so that we can, you know, find out what that value is and assign it to something else and use it as a value. The purpose of the getting is not just to print it to a screen. It's not for user interface purposes. For user interface purposes, we want to put it out here. So this is kind of like when you start thinking about how to separate the logic. Because a lot of people would go and, you know, a get, oh, you print it to the screen. It doesn't do anything, you know. So now I'm going to print it to the screen out here because I haven't actually printed anything to the screen so far. So I'm just going to do a system out .print line. And we go, oh, okay, well, we're going to print a string object. Here's print a string object. String argument. What's my argument going to be? It's going to be here is the output. And I'm going to go system out print, oops, first value, first temp, equals, that looks good. I want to print out temp 1 dot get temp. And I notice I have a typo, so I'm going to go like this single one. Oh, and I have another typo. And I'm going to go that and go like that. And so now it's going to say, and it kind of does the same thing every time you use a method. It kind of just, and here I just sort of print. So it's not gonna. Actually, I could do a print line here. Let's see, put a little line return at the end of it. So now if I kind of like wanted to see this run, just to see it run, I can test it at this point, or I can continue writing more stuff. So I'm going to do what I normally do, is just close things, because it asks me to save it. If I don't save it, nothing runs, just the problem. So I'm going to save that. This one is actually from a different project, so this one actually hasn't been saved either. So I'm going to say yes. And then if I come back up, see, are they both saved? Yes. But this one has an error. What does this one say? Type. Well, it didn't use type at all. I just used the float. So now I'm going to go back up here, and I'm going to say, why are we not running? Run as, and I didn't really, well, before a few minutes ago I clicked on this file here. I clicked on it, so it doesn't really matter. In fact, this is the interesting thing. It's a little bit inconsistent. You could use the menu up here and go run, and then have to select application applet. You can actually set the default so it always runs it as an application. You can click on the selection does not contain a main type. Yes, it does. Oh. Oh, there we go. I had to create the configuration because I added the classes to the package, didn't actually save the package. That's the other problem. And that's why I say, don't get frustrated with this. It's just inconsistent. And, you know, it should think ahead of time and go, you need to save the pack. I didn't save the package. I created the package. The project is what I meant to say. I've created the project, I added the files to it, I saved the file, I never saved the package. So if you see that run configuration, just go, okay. It saves it, and it tells you that this is a packet, this is a project, and these are the two files in the project. Because what the problem was a few minutes ago is it couldn't find main. So when it said, if it can't find main, most likely you didn't save it. And if you save the file, you didn't save the project. That's what's the bottom line is. It's really not the configuration that they're thinking, you know. But okay, I run the wrong package. What is this? This is the wrong output. To my temp is set to C. No, this is first output, this is second output. This is the wrong package. I'm in the wrong package. Hold on one second. I have too many projects open. Hold on, let me go back to temperature. Might also help if I run the right. Yes, it does. What do we have going on here? Let me just. Just slight. Hello. Challenge today. You double click on it, it's supposed to open up for you. Okay. Open project. And you normally when you double click on it, it's supposed to open. It's not having main type. There's something wrong with my project configuration. Should work just fine. You mean up here is what you're talking about? Let's fix that. Maybe it has to for Eclipse. Let me just take a look quick here. Let's see. It should there. I can go out to terminal prompt and compile both of them and they'll run just fine. But let me just see why this isn't working. Maybe I've got to do this. That would be odd if it required that, but it seems like the only thing I really could possibly fix at this point. You're right. Now that isn't interesting. This is just our little troubleshooting. We work good as a group. So, work well as a group. There we go. So, interesting. Oops, I don't want that. The interesting thing was we actually, well, okay, so in the future just cut and paste and use the template of what they provide you. You don't actually have to put arguments in here though. It doesn't work. It's weird actually. It's an Eclipse issue again. Because I can go out into the terminal prompt or DOS prompt and compile just fine with the Java. So Eclipse is looking for the arguments apparently. I didn't know that. It's actually kind of interesting. I learned something new today. Another idiosyncrasy of issue with Eclipse. But anyway, as you can see on the bottom here, let's get focus back on the example now. We're running the correct one. Temp set. What did I do? Why did I do that? I don't know. I have two of them though, and I have. Oh, because I put something, I believe, in the driver class that said that. No? Here's the output. First temp is equal to 2.0. Let's see if I can get this big enough so it fits on the screen here. So now I have temp set from my two object instances that were created, and temp set is it's not in here. Yep, it is. No. Here it is. Here it is. Set temp. I put temp set in here. Which now you go back here and you go, well, why is that showing up on the screen? That's why you don't normally want to do that. Because then you get stuff like here that happens, and you're looking at the driver program, and you're wondering, where's this temp set coming from? So if you put all the systems out and all the output essentially in the driver program, you have more consistent ability to kind of go back and find out and change the change the way it looks, modify it, troubleshoot it a little bit easier. That I did create two objects, and when I created two objects, I set it. So, and then I have here here is the output, which is just a line that I printed, and then in this one here, when I didn't use the line on this. I got it, so it said first temp is equal to 2.0. So, believe it or not, that's all you need to know about system I/O. So, because most of what you're doing is going to print just print something to the screen. So, another thing we could do to modify this, and I'm going to talk about this a little bit today in another example, but I want to kind of get into the concept of inheritance and objects soon. Is in here we could have had a toString method. Where we could create a method to convert a float or double, like maybe our character, to a string value. We can also take And, you know, as a standard in each one of our classes, we use the toString method. It's usually at the bottom of the class, and it's just basically used to quickly convert the object, because we know the data types, just basically convert them to a string so that when we do print them out, they come out looking like we want them to look instead of like values, numbers, and stuff. But the system out, as you notice, though, will take anything. System out printed a float, no problem. And I used the get method, the get temp or something. Yeah, I used the get temp to get that. So actually, questions, comments, concerns about the assignment? No, it's the template for you is there. Actually, this is being recorded. If you missed any of it, you can watch it, take it, pause it, and type all the stuff in and do it. You know, do it again if you wanted to. It's important to actually kind of take some time in the beginning to just manually type stuff out like that, because it serves a couple purposes. I mean, it definitely raises your confidence level in terms of the programming interface. It gets you started, gets you more familiar with what you're doing, and then you can tackle stuff like, you know, creating this here, which is not really that bad. The only problem is you have to work with data types, you have to do some addition and subtraction, and there's a lot more functionality that you'll need to implement to complete this assignment, but you have about half of it done already, I would say. So I'll leave that to you and move on to bigger and better concepts. And if you came in late, you didn't hear what I said about this, you don't have to take the command line arguments and do it this way. So this is driving it, driver space, and then typing it in, because if you're in Eclipse, you can't do it. But, I mean, when you run it, it's just automatically going to run. So you can make it run like I just did a few minutes ago. You don't have to do this. But if you want a challenge, and you're serious about programming, do this. It's actually a pretty good exercise. It gets you familiar with the strings and the command line arguments. So. Questions at this point? Okay. Very good. That's what I like to hear, no questions. Did I finish? I think I finished the last lecture, didn't I? I think I did. Lecture number 4, extending classes. Now we're moving into inheritance. This is inheritance. Outside of creating an object, which we just did, the only way to learn it is to create more objects. So keep creating objects. But after you create objects, you wonder, well, what am I going to do with these objects? Well, now you start thinking about the concept. You start thinking about inheritance in terms of how you're going to use it. So inheritance. You can create new classes that are built on existing classes. That's the object of the objects. So through the way of inheritance, so you're going to reuse the existing classes, methods, and fields. So you can also add new methods and fields to adapt the class, to change the class to new situations. Classes, we have superclasses and subclasses. A subclass can be a superclass. A superclass can be a subclass. So we have a hierarchy. It depends on where it lands in the hierarchy as to what it actually is going to be identified by. Programmers don't go around going superclass, subclass, super. It's just the theory behind it, so don't worry about that. Subclasses and superclasses have an is-a relationship. This is what I was talking about before in terms of what type of object is this? It's a employee, it's a student, it's a person. So you can go up and through the hierarchy. Every object that's inherited of another object is both objects. So now we have multiple personalities. So these objects are mentally insane. So an object of a subclass is an object of the superclass. So just think, when we are creating a superclass, we're also creating the lower class too, the subclass. Here's a class example. So public class person. And person has a string name. And then we have person. In fact, let's see this live, because then I can make it bigger. In that download we did yesterday, we had perfect. We had some stuff in that file. This is the same file we downloaded yesterday. It has an employee, boss. I don't have person in here. Thought I had person in here. Hold on one second. Let me just check one more source before I go back to that lecture, because I don't like the type font in that lecture. Let's take a look here, quick look. I'm going into the bhacker.com course materials down on the bottom for the lecture examples, and I have an example here. This, I believe, is the one I'm going to want, inheritance, example number 1. It saves me from having to retype. So let's just save that one. While I'm out here, let me see if I need anything else for today. This one I already downloaded, but that one doesn't have... It has a simple inheritance in it, but not that much. No, I think inheritance example number 1 is the one I'm going to want. I think that's going to match the lecture, but let's just take a quick look real quick. Yep, there's our... No. Here's our person. Okay, let's put this one in. This is good. Person, inheritance 1, inheritance 2. Okay, so... This is what I wanted. Here we go. Give me a minute. Lecture. I believe that's lecture 3 or 4. 4? Lecture 4. Let's do that. I have to get organized. I'm feeling unorganized. Alright, so lecture 4. There's probably a more efficient way of doing this as well. But I don't have a project created, so I need to create that project. I just ordered this file, so I'm going to import it all into here. So I'm going to go File System. Yes, next. I showed you guys this yesterday, actually. Great. That's not what I want, though. I think it's on the desktop. I think it's this one. That's the one I want. And I don't want that one, but I want everything else. Okay, very good. All right. Let's just see something real quick. Okay, good. We're good. I just want to know. I'm paranoid about Eclipse. Okay, let's talk about person. Actually, let me close this. Let me close this. Let me close this. Oops. Here we go. And don't listen to her. Okay, so these are bigger, more colorful, more interactive than the PowerPoint slide, which is kind of like why I like this better. We're going to build a hierarchy, and the PowerPoint slide actually had a person in there, and it had another example, and these are the examples from the PowerPoint slide, which is showing a superclass of person and a subclass of student that extends person. Because every student is a person, and every person has certain things like names. I added a few more things. I'm trying to take a look there. I did add a few more things in the subclass student, which varies a little bit. But here's our person. And so when we start creating this is going to be our base class, or originating class, and we're going to inherit from this class. So this just looks like the temperature class I just wrote in a lot of ways. It's got a constructor. It doesn't do anything. It's got another constructor that sets the first name and the last name. We have a first name and a last name. We don't want to put anything outside of the concept of a person in here, though, because people can be employees, then they're not going to have a student ID. You know, if a person is an employee, but if a person is a student, they might have a student ID. So we basically modify through the inheritance all of the different added data members that are going to be part of the concept of the person. When we take and create inherited classes from this, we have a person as a base who turns into a student, who turns into an employee. Then what we end up having is the ability to say, well, this object is a person. Okay, so this person is this person. And then we can swap the people around, compare people. We can do a bunch of stuff to the people at a people level. We can do a bunch of stuff to the classes student level or as an employee level. So that's kind of the concept that we're working with. And the reason why we're doing that is so we can isolate the behaviors and the role and keep these objects down to single identities. So a person, everyone's going to have a first and last name. It's kind of big. And we could put age in here. We could put all the data members associated with a person. We've got a constructor here that sets the name, set first name, set last name. And here's another interesting thing that I showed you, which is why I kind of like this example a little bit better than the one in the text, or one in the PowerPoint, I should say. I'm running method calls inside of a method. So this is kind of interesting. So why reinvent the wheel with a constructor? If you're going to have a method that's going to set and get, and here I've got a set first name, get first name, and I'm going to have the functionality built in. I can just create the constructors and run the sets and the get methods inside of the constructor, rather than having to retype the code all over again. So it's common. It will be common to see method calls inside of constructor calls. So, and here we have a get full name down here, and it's going to be a string that's going to return a string. I'm still not using the toString yet. Save that for another lecture. Another example. In fact, actually, I think one of these pieces is going to have that in there as well. But get last name, get first name. So, are we all kind of comfortable at this point with the concept of the person class? This is what we're going to take, and we're going to extend the functionality. So, let's just assume we are. So then, a person can be an employee. And so here is our inheritance right here. It's the keyword extends. So we say public class employee extends person. If we took off extends person, it's not going to include anything from person. But an employee now, this is assignment number 2, but we don't know it yet. This is code for assignment number 2, by the way, if you're having problems with that. We've added a bunch of stuff. Oh, we went back and we added from lecture 1 the next ID, or lecture 2 or something, from yesterday. If you remember that static integer next ID, because we're going to keep track of employees. We're going to give them an employee ID. So we're going to do it at the static level, which means it's a class variable. And in here we've got a really bad example. I mentioned before, we're incrementing it. So private ID is equal to next ID plus plus. We're adding one to another. So we're changing that static into making it a method making it a data member for the class by assigning it. And then we have a department, pay rate. Notice in here we don't have anything associated with first name and last name. So when you're thinking about it, just take person and assume you have first name and last name and everything that you needed inside of this. And you're going to use that. And then we have our default constructor employee. We're not going to put anything in it. It's empty because we have to include it. And we're going to create an array of dependents in here, but that's because we're working on the assignment. But let's forget that part right now. And a couple of other constructors here that are taking on first name, last name. And here is why I wanted to show you this example. You can say this to yourself, we're supering back. Or super. Super means go back. Go back to person. This is an employee class. We extended it from person. We don't have first and last name up here. First and last name belongs to person. But now we have a constructor employee, which is taking on a first name and a last name. So we use super to say go back, super back to person. First name and last name. Super is sort of like this. Super says go back and run the constructor that matches the first name. And this is basically saying go back and run this constructor. Right here. It's saying super, which says go back and run the person class constructor, then give it these two parameters, first name and last name. So we just sent it backwards. And now this is going to be assigned for the person. So we didn't overwrite it. We didn't overload it. We supered it. So, which is the this and the super, it kind of works in sort of that fashion. Because we can take we can use this outside of this. I mean, we can go this person's first name and last name, or get this and super it back. So let's go back to employee. That enables you to move between the hierarchies, essentially. And then we're doing it again here. But now we're doing, well, we're doing it both in 2 lines. So, because this is a constructor that is in part of the extended class. So what ends up happening is all of the constructors fire. And it starts with the current employee, and that runs first, and then the next one's going to run is going to be the person's constructor. So they all fire, actually, in order, which is why you kind of want to arrange the constructors so they're logical, and it makes sense. Because here we're going to super back the first name and the last name. We're going to take it back to the other, run the other constructor for that. Now this one we're going to set the department, because we don't have a department in person, but an employee has a department. So, and then we're going to set the pay rate on this one. This one's going to take the pay rate, bring it in. And this is interesting. Now we're going to go, on this one we're going to go this, first name, last name, department, which is kind of interesting. Because it's going to fire anyway. Because it's going to look and say, first name, last name, well that's person, department, well that's employee. So we're setting it from, and it's kind of just a play around kind of thing. I would use super probably but this has got, we need this to go this department. Because we put something in here that was from this, and not super. But it's going to know it anyway. So it's pretty smart in terms of how it's going to find the constructors and how it's going to run. And it's kind of tricky, actually, sometimes when you get this unusual behavior and you go, well, what constructor was that in? And you actually, some people actually kind of like map it out, especially if the inheritance is pretty deep, to actually figure out, well, where is that activity coming from? Where's that behavior coming from? Because what you don't want to do is go ahead and overwrite it or overrule it when you don't really need to. You don't need to overload it and overwrite it. So. But that is a form of overloading when you, in other methods, you can essentially do that. And I'll show you that in a few minutes as well. So the rest of this is not anything that you need to be concerned with at this point. In the inheritance one example, just to take and go back to the concept itself, I did something in this, and I totally encourage you to download this zip file and go through these examples. But the one that's called inheritance number 1 takes, and it's kind of really basic. It takes a base class. So now we have my base, and it has integer x in it, and I've got a default a constructor, and I have a getX, a showX, and then I have class my derived class that extends. They're all going to look the same. So after about 2 or 3 more examples, you're going to go, the only thing different is that it extends it and it includes it, which is what you're doing. So it extends base class and it adds y. So now I have my derived class has x and y in it. And then it's going to say, well, super x, send x back to this constructor up here. So we can set x, and then this y is going to be equal to y. And you notice I didn't use this and then go x, comma, y. I didn't actually do it that way. Instead I broke it out, which is, you're going to find this to be a little bit more common. Super it back, and then that goes back there, and this goes back here, so this y is going to equal to y. Because we might have a y somewhere else, we don't know. Get y, set y, show y. And then we have, and this is kind of a sloppy example, but I thought I'd show it to you because when you're messing around with it just to understand the concepts, it does sort of make sense to put it all into one file. And here down here I've got my driver program class inheritance 1, which is actually the name of the file that I created. Notice I don't have a name on the file that is associated with my base or my derived class, but they're in here. When I compile this, if I take this out into the command prompt and I compile this file, run this file, it will run just fine, it will compile just fine, and I'm going to get 3 classes that are created. I'm going to get inheritance 1, my base class, and my derived class. It's not going to put it into one file, which is kind of interesting. It knows and it separates it out. If I run this, Let's see if it runs. There we go. It will run. Yeah, there we go. Confidence. It will run. And we have we created this, so this is the driver program for it. My base B is equal to new base 2, so I created one with base 2, and it ran the my base. And then B.show, it showed out X is equal to 3. My drive D is equal to new my drive 3, 4. D.show, and I got Y is equal to 4, which is going to be, if you go back and trace the behavior, it's going to be, showing you how the constructors are printing out. Because in the constructors up here, I put a show. Well, actually, this show is what's printing it out. B.show, D.show. But D is a derived class and B is a base class. So the show here is printing out from this object, this type of, so it's actually running the show method from one from my base and one from derived. Because we've got a show here in my base, but the method's the same. Although the objects contain each other, the object, you're treating one as a base and one as a derived. So you're not going back and treating it like a base when you run the show. In inheritance example number 2, we have purple. So this is going to show you the constructor order, actually. So class purple has a protected integer I, which is going to be equal to 0. And you're going, protected? We haven't seen protected yet. This is the first time we've seen protected. Protected means that inherited classes can use it. The public can't. So same thing in C++. We have public purple. The default constructor is going to say purple running, and I is equal to I. And whatever I happens to be, I here is 0. And then we have another one that says purple I. Purple is going to take in I and set it to this I. And it's going to say purple running, and I is equal to something. It's going to be whatever the value is after we set it. Then we have class violet. Violet extends purple. Anything about violet is just kind of a variation of the color purple. So violet, here's our constructor. So violet I is running, and I is equal to something. And then violet I here to constructor to take in. This is kind of basic. Another constructor to set it. The same behavior is performing in purple as it is in violet. And our inheritance, this is the only line of code that actually creates our inheritance. Otherwise, everything else is kind of treated as another class. Here's our driver program. Again, kind of sloppy programming, but it's for illustrative purposes. We have inheritance number 2. And we have new violet. And we're going to run new violet 4. So we're going to run both. We're going to create, and this is, again, another kind of sloppy way, because here's the interesting thing. New creates a new instance of an object. We don't have to assign it to a variable to use the variable object. So in the past, what we would say is we would say violet as a data type, my violet is equal to new violet, my something, violet, my something, violet number 2 is equal to new violet, and we kind of use that format. This will actually work no problem. It just means we haven't assigned it to an object yet. It's an unassigned, newly created object for illustrative purposes, and also to show you that it works, that you can actually just go new violet. Because you don't necessarily want to use the object, you're just going to create an object instance, but you're not going to manipulate, you're not going to run any methods. You can't run a method on this because we don't have a name object. We have an unnamed object going on here. So doesn't really work in a lot of cases for very much. Now, where's this purple coming from? I created 2 new violets, but I've got purple stuff going on. So I'm going to trace it through the constructor, and I'm only going to do this one time because it can get kind of boring after a while. It's like dominoes. In fact, I once knew of an instructor who gave a midterm exam, and they give you output, and you have to say, well, what constructor is that from? And there's like 10 deep inheritance, and you have to go back through and you have to trace the constructors. That's a nightmare question. I would never do that to you. And this is the only time I'm actually going to trace them because it's tedious to go trace back through the constructors. But what this is trying to illustrate to you is the constructor order. And then when I go back to the PowerPoint, I have an example there. It goes, I think, 5 deep. And you'll look at that and going, why? It's an exercise in tediousness. But for troubleshooting purposes, you do sometimes have to go back and go, oh, why is this happening? And then you go, oh, some idiot put the employee ID in the person constructor. It doesn't belong there, and then you have to switch it, see if you said it correctly. Purple running I is equal to 0. This came from new violet, which means new violet. Before it became a violet, it was a purple. Because we have nothing. New violet over here prints out violet. Violet, but before it became a violet, it was a purple. And purple said, purple running and I is equal to I. Well, I was 0. I was set to nothing. Now we get violet. Violet I running is equal to I is equal to 0. And now we have violet, so we have this violet here. Violet, oops, here we go. Violet I is running. So, oh, I forgot to put the I in my purple. I don't have an I in the purple printout. So you can, and actually I think I remember at one point I did this because a student had a question and I was trying to run it through it. And when I saved the example, I forgot to put the I back in. But it kind of shows you this is where this is where this purple's coming from. So that's where this is coming from, is from that, before they were born, they were a purple, then they turned into a violet. And then now we just have the same thing going on here with the purple. And this was actually put in as an illustrative purpose to show you we didn't run the default constructor. We ran a different constructor, but it still went back and ran the default constructor on purple. So purple still ran the beginning, and then we ran a different one for violet here because we set violet to 4. Interesting, I is now equal to 4. I is not in here. Purple does not contain an I. I is over here. Excuse me, violet does not contain an I. Purple contains the I. I was set to 0. However, it's protected. If we made this private, we get an error message. And we go, what's wrong with that? It looks fine. Well, violet can't touch it. But we made it protected so violet can touch it. So you'll see protected all the time. You'll never see public. You're going to see private and you're going to see protected on these data members. And here's where you're going to see the public. So going back to reiterate that point. So violet I running is now I is equal to 4. I got sent back here. I got sent back with this method because we took in I from the command prompt and we set I over here in purple. So and I know I've kind of drilled this in kind of slowly, hopefully. If you remember that, everything else is just like that, but it gets more complicated. So it doesn't get that much more complicated. So I want to go back and pick up the lecture. After I get done with this lecture, we'll take a break, so don't worry. We're going to do a break soon. Oh. Super? Only runs it once. Oh. Uh-huh. It actually creates 2 objects. It will create, every time I create a violet, I also create a purple. Which is why I wanted to show you that, because it ran the constructor to create both. Every time those constructor runs, it means a new object was created. And so when I created that first violet, it created a purple and a violet. Created the second one, it created a purple and a violet. So we had 4 outputs going on with 2 object creations, because we actually have 4 objects being created. Every violet is a purple. Which is kind of weird. You think about it and you go, wasn't that kind of a waste of space? But we have garbage collection and we have better JVM management, and it allows us, thinking about the concept of is an object, it allows us to go backwards. So it's like multiple personalities, but they're multiple objects that exist out there. So we actually have 4 objects going on. So let's see what we have here. I think I'm still zoomed in. Here we go. We have the superclass, we have the subclass, and now I can kind of go through this a little bit quicker because I already showed you kind of the real time, but there might be some points in here that I've missed. And so class person, and then we have class student that extends person. because every student is a person. We have the name here, we have the student ID, student number here, we have methods that are associated with person, we have methods that are associated with student. When we say super here, they're both public, which means they're both going to run. This is just, it's just kind of like saying the this. It just says, it's just kind of an explicit way, instead of using the implication, it's just an explicit way of saying when we create a student, we have to run person constructor, we have to run and create a, we have to basically, otherwise we're going to have a no name. We're not going to have a name set if we don't do it. You can leave it out and you'll get the same behavior. So I actually did not show you in the purple and the violet. We didn't run super, but we still had all four of them going on. But for illustrative purposes, it's common to see the super in there, which means it's kind of also a way of making sure that it works, because in some other cases it may not necessarily work. Depends on how you've got the protection set. That will generate an error message if something is private and you can't do it. So, what do we have here? More constructors, and we have a set and a get. So hopefully you're starting to get the impression, set name, get name. That's my preference. You don't have to do that. You can call it something else. So here's our class hierarchy. Every class is an extended or inherited class. Whether or not it is, your hello world is actually an inherited class from object. Everything is inherited from object, which is what this illustration is trying to tell you. So it doesn't, even if it's not declared, it still comes from object. So object is a person, is a student. So technically, we actually have 3 objects, not 2. When we create a student, we actually have a person and an object. You will see object being used as passing the object through a method call. Because here's the interesting thing, and going back to what I said about typecasting, everything's an object. So you can cast student as an object and switch it with another object, or use another method that, let's say, just takes an object and prints all the contents to the screen or something. Well, then it can print a student, it can print a teacher, it can print a person. So you'll see, sometimes you'll see the object passed as a generic object. It means it's basically treated it like an object instead of a student or a person. Makes it compatible, especially for polymorphic type of behavior. Fields and methods in the extended class. An object of an extended class contains 2 sets of variables and methods. Then you can imagine how complicated this can get when you have 5, 6, 7, 8, 9, 10 classes in a hierarchy. Then you go, where's that from? Because you're not reinventing, you're just using, you're extending. That's why they use the keyword extend. Fields and methods which are defined locally in the extended class. Fields and methods that are inherited from the superclass. What are the fields for the student object in this previous example? It's everything. Everything from student and everything from person, all combined into one. And here's our formal, and I'm going to call this a summary at this point because I kind of showed it to you already. Constructors in the extended class. So a constructor in the extended class can invoke one of the superclass's constructors by using the super method, which is what we saw there. So super. So if no superclass constructor is invoked explicitly, then the superclass is non-argument the default constructor. So if we left out super, it would run the default for us automatically, which we saw with the purple and the violet. If we put super in there, it's going to run the one that matches the constructor that we're running in the extended class. Because we took on, in one of the examples I showed you, we took on arguments. So we supered it back to run the first name, the last name, and we had, what was that other piece of information? Department, I think it was. But so it supered back for first name, last name constructor instead of running the default constructor. So it could set the first and last name, and then it used the current extended classes constructor for the department number, which is where that super came in. So it's invoked automatically as the first statement of the extended classes constructor, just like this happens. You just put super, open and close at the beginning. It just says explicitly run that constructor for us. Okay, constructors are not methods and are not inherited. So methods, constructors are not inherited, which is kind of interesting. It's just functionality that we turn on and turn off when we want to use it, don't use it. So here we have the 3 phases of the object's construction. So this is the beginning of life for the object. We've seen it live, but here's the text. Here's the theory behind it. When an object is created, when an object is born, sounds like an old health movie, memory is allocated for all of its fields, okay, which are initially set to their default values, hopefully by some sort of a default constructor. It is then invoked in 3 different phases of the constructor. So the invoked as superclasses constructor initialize the fields by using their initializers and initializing blocks, and then execute the body of the constructor. So it goes back to the beginning. A violet creates a purple, and then it creates a violet. So it goes backwards. So and that's the hardest thing to remember, is kind of keep the logic in mind. It's not really hard either. The invoked superclasses constructor is executed using the same 3-phase constructor mode. So this process is executed recursively until the object is reached. So it goes backwards, runs everybody from the beginning of the object all the way to the current class, the extended class that you've created. And here's that lovely example that I was going to show you, that you're going to look at and go, why? Oh no, why are we doing this? And there's a sadistic teacher out there that gives you like 10 of these things and says, you know, fill this in. And you're like, oh no. We have class X and we have class Y that extends class X. And we're using protected because we're going to use inheritance here. We use protected over here too because we don't know. We might have a Z. Add Z to it. So we have which order is equal to X order, and then which order is equal to Y order. And when we set it with the Y object Y is equal to new Y, we create Y's. Then we got X's and Y's being created, and we've got the combination that's occurring. So we're using both X's and Y's, and we're only setting, essentially, we're only creating a Y object. So I'm not going to go through this example because it's too tedious, but you can go through and you can fill in the blanks on your own, and you can, and there's no blanks to fill in, it's filled in for you, but you know, you can probably get what I'm talking about, hopefully. Yeah? Uh-oh. Base class is going to run first. X is going to run first, then Y. But think about it, it always goes back to the beginning of time. It will always go, actually, it goes back to object first. Creates the concept of the object, then it creates the next class, and then the next class. So that's why they say super back. It just goes back to the beginning. That's why I always use that terminology. And I don't know. Some people get it, some people don't. But it means go back and recreate it from the beginning. And so go from object all the way to the current. So, because you actually have to think about it. I mean, you have stuff here you're using that hasn't been set yet, that you're assuming has been set. So until you go back and set the first and the last name, how are you going to set the from person, then in employee, you can set the department, and then in teacher, you can set the department, the teacher's whatever, social security number, I don't know, stuff like that. Overloading and overwriting methods. So here's the pieces. We've seen it kind of. Constructors aren't methods in terms of overloading and overwriting, as we've seen, which is why we're using super in this and stuff like that. Overloading provides more than one method with the same name but different parameter lists. So we have a set name as an example, maybe. I think I have one in that example. I'm not sure if I showed it to you. I don't think I did. We just use the same name again. So if a previous object has a method that's called something, if we use the same name again, we're going to essentially override it. If we call it, or we just run it as if it's included and we modify it, we can overload it as well. So we have both of the options. So overloading when more than one method with the same name but different parameter lists. We've created polymorphic behavior. So now instead of set info, the set info of person might have first name and last name. The set info of employee might have first name, last name, and departments. So as long as we change the parameter list and we say set info and we give it 3 items, it knows to run the one from employee. If we gave it 2 items, it would run person from our employee object. So we have it until we override it, we can use it. So overriding allows us to do all of them and creates polymorphic behavior, essentially. because we're doing the same thing, but we're sending it different parameters, different types, different things, possibly. So overriding replaces. We no longer get access to it anymore. We replace the supers implementation of the method with our own design. So now in fact, I always use the concept of area. The area of a circle is different from the area of a square. It's different from the, in terms of the shape concept. So you can override the areas. Override the areas to change the way the calculation is done, because if you ran an area on a square and you're looking at a circle, it's not going to come out right. It's not going to give you the right answer. So both the parameter list and the return types must be exactly the same. If you rewrite the method with the same number of parameters and the same return type, you're going to overwrite it. If you change it slightly, use a different return type, you're going to overload it. And here's the issue. Then we have students who forget the return type, and then they just leave, they maybe accidentally make a different return type, and they've overloaded instead of overwriting. And then we have people that just override everything. They don't overload. Because they figure, oh, it's a person. No, it's an employee. And then they're setting the name, first name and last name, in the employee class instead of using the person class. So when in doubt, overload. When you have to, override. In the example of the square and the circle and the figuring out an area, you can't overload that. It's a different calculation. It's a different formula. So you gotta override it to get the right area to run. So in an overridden method is invoked on an object of the class, then it's superclass's version of the method that gets implemented. It's backwards. So when you overwrite it, it works here backwards. In fact, overloading works in the same direction, but what will happen is it searches from the beginning of the object to the current object to find the method that you're looking for. So, an overridden method can have different access specifiers from the superclasses version, but only wider accessibility is allowed. If it's private, you can make it public. So you can scope it wider, but you can't scope it narrower, which is interesting. So if you start out private on everything, then you can start making it public if you wanted to. And actually, I shouldn't say private. Protected is what you're looking at in terms of that. The overridden methods throws clause, and we haven't took that, or we haven't had a lecture, probably not till the next class meeting, on exception handling, where we have a throws clause that throws an exception. And in that particular case, the throws clause can have fewer types listed in the method in the superclass, or more specific types. The throws clause can vary. It doesn't have to be identical. So it can definitely be altered. Accessibility and overriding. So a method can be overridden if it's accessible in the subclass. So we'll go back and kind of look at private again, package and protected and public, because this is the source of confusion sometimes, but it's just, that's when you see people going back and making everything public. If you go back and you see everything is public, that's a red flag, and things, oh, they don't know what can be overridden. So now everything's public. It's not safe for the class, but it works. It solves problems, actually, but not a good way. Private methods in the superclass, superclass, cannot be overridden. They're private. So if the subclass contains a method that has the same signature, which means it takes on the same number of parameters and it has the same name as one of its superclasses, these methods are totally unrelated. So this is bringing up an entirely new point, which means if you make it private, it's not visible, it's always there, cannot go away, cannot be overridden, cannot be overloaded, and it's runnable and it's accessible from that object. So if you have a person who is now an employee and the person has a private method in there, you treat the employee, you type it to a person, and you run the method. So that's when we're going to use, and we'll see it. You treat an employee like a person so you can run it like a person. And that's when you use actually put in person. You take the object, you typecast it to person, so that it's a person, so that you can run the private method of that particular person, and then it works just fine. You do that when you want to retain it. You don't want it to go away, because private is private. It's to the class itself, and if you want to have that functionality, you don't want it disturbed elsewhere, keep it there. And there's nothing wrong with that. Package methods in a superclass can be overridden if the subclass is in the same package as the superclass, which is kind of the same rule you get with overriding in terms of the inheritance. Protected public methods always will be protected public methods. not as simple as it seems, but not as that simple as it seems. It's a tongue twister for today. I need to edit that. Not as simple as it seems. Alright, so here we have a sample class. Package P1. We'll package in here. It's just to illustrate the example. Base, we're importing P1.base. You don't actually have to do it this way, but you can. And we have concrete1 that extends base. And we're doing this because we're in the package level, and we're going to show all the different pieces that you can possibly do in terms of the arrangement. And when we print it out, this is kind of like my violet and purple. It's going to print out both. So we created a C1 is equal to new concrete1, C1.show. This is purple and violet all over again. So we have base, concrete, we get 4 instead of 2. And then we have concrete C2 is equal to concrete 2. We show it out. We get the base. And we've extended. What have we done here? We've created, we're overriding and we're overloading. So I actually don't like this example because I like the purple and the violet better. So you can download the slice and go through it at a slower pace, and you can go. And I think it's just too tedious to trace back each one of the constructors. But what we've done there was an example of overloading it and overwriting it and showing you the output of the shell. Hiding fields. Fields cannot be overridden. They can only be hidden. They can't get, and these fields are the data members, by the way. It's another word. Field is another word for data. If the field is declared in the subclass and it has the same name as one of the superclass fields, then the field belongs to the superclass. It cannot be accessed directly by its name anymore. Makes sense? You've changed the meaning of the name. You've gotten rid of the inheritance, essentially. There's some reasons to do that. If you declare the variable again, it doesn't go back. It replaces it.
So which one will take it?
Superclass. Yeah. If I have a person and it has a name, and it has a first name and a last name, and I have an employee that was mailed from person, an employee has a first name and a last name. No more first name, last name in person. We have it now in employee.
So no more first name and last name in superclass?
It'll use, if when you repeat the data members, those fields, in the superclass, you redefine them in the superclass. It will only be in the superclass. I'm sorry? Yeah. There's really no need to do it. You could just, it's not a good practice. Yeah. But if you use the same name, it basically hides it. It can't be accessed anymore by its name. You can't use it as a name from a previous class if you've redefined it. You want to basically keep, what you want to do is bring forward, keep it and add to it, supplement to it. If you start using the same names over again, if I now have a first name and a last name in my employee, I've got a first name and a last name, I can't go back. It's still there, but I can't go back and use it. There's no way of getting to it. I've redefined it. It's kind of like how we've overridden methods. We can override fields. When we override them, it's not that we've gotten rid of them, we've hidden them. We can't do anything with them anymore. Person has a first name and a last name. Yeah, it's done by mistake a lot. Yeah. So if person has a first and a last name, and we inherit employee from person, and we go first name and last name, how are we going to know which first name and last name we're talking about? It's going to use the last one we created, which is going to be the one, in employee. It's overriding it, essentially. But we're not really overriding it. It's still there. We just can't get at it. There's no way of doing it. We can get at it through the methods. No, actually, we can't. It's going to be hidden. The point being, it's kind of it's an accident. It's a mistake. Unless you want to replace it. Maybe it's a specialization, and you have a need. There's nothing wrong with it. It just there is a way of losing it, and you're not really losing it. You just hide it. It becomes inaccessible. It's still there. It's still taking a memory, actually, too. But people do that. They don't do it by mistake in the same class either. You have a data member, and then you create another data member with the same name, and it works to a certain point. And then all of a sudden, you start noticing. Because, you have first name, last name. And then in a method, you got first name, last name. And you're just going to use that one. It's going to use the second. And then it's going to go back and say, well, how come it's not set for the class? And it actually is set for the class. But then you run into this really weird scenario where you have to, do it this way because it's here, but it's not here. It's better to follow the rules in terms of if your intention is to have a first name and a last name, make it a field for the class and leave it alone. Don't reuse first name and last name anywhere. So, polymorphism, whatever. Polymorphic behavior. An object is an object of a given class can have multiple forms either as its declared class type or as other subclasses of it. So here's yet another definition of polymorphic behavior. When an employee turns into a person and then turns into an object. What are they doing? They're morphing, they're changing, transforming, but they really are the same person anyway. They just have multiple personalities and are switching. The employee is going back to be a person, going back to be an object. You can do that to get compatibility among objects. All you guys are people. Well, actually, all of you are students, too. Some of you might be CS students, some of you might be CE students. Then that's where you change. But if I want to treat you as a student, I can go back to the student level and forget about your specialization and say, oh, yeah, but you're all students, and morph you back. That's polymorphic behavior as well. An object of an extended class can be used wherever the original object is used. So that's where we come back into that concept of compatibility and type casting. It's not casting a type, it's polymorphic. It's transforming that student back into a person, or that CE student back into a student, which is different than casting in C and C++. And casting in C and C++, we're taking normally a variable and we're typecasting it one type to another type, and we're translating the type. Here we're just going back through the hierarchy, is what we're doing. So it's casting, but it's not converting. We're not converting anything. So, question, given the fact that an object's actual class type may be different from its declared type, okay, then when a method accesses an object's member which gets redefined in the subclass, okay, then which member of the method does it refer to? Well, to current object, long story short. So when you invoke a method from an object reference, the actual class of the object, its current type, its current class, decides which implementation is going to be used by what's visible to the current object. As an example, you are a CE student, and I have computer engineering, and I have computer software engineering students, SE students. And I create two sets of these students, and then I cast you back to a student. You don't have any SE and you don't have any CE information. You're no longer an SE or a CE. You're all students again, which means I can only have visible to what's on the student level. Which, if I'm doing that polymorphic, if you're a student, I have to treat you like a student. I can't treat you like a CE anymore. But I can always put you back into the CE. I can always go, okay, person X, You're an object, you're a person, you're a staff, you're a student. Now you're a CE. Okay, now you're a CE, and I take it from that level, and then I can have access to all CE methods and things. So, let's see. When you access a field, the declared type of the reference decides which implementation to use, which is kind of like what I was saying before. And here's another one of these lovely examples which I don't like. So I'll show you that with the assignment number 2. We're going to do assignment number 2. So I'm actually going to show you assignment number 2, more of it than assignment number 1. So because it's hard to get it unless you see it. And for those of you who are actually here, you get the privilege of not actually having to do it yourself. But half the class is not here, so those guys will struggle on their own unless they watch the video. So type compatibility, let's talk about that. Java is strongly typed language. Although it doesn't sound like it, it is a strongly typed language. In terms of the compatibility, when you assign the value of an expression to a variable, the type of the expression must be compatible with the declared type of the variable. Obviously, it's the same thing that you get with C or C++, also a strongly typed language. It must be the same type as or a subtype of the declared type. That's where we get differences. So the type is compatible with all of the types that are inside of the existing type. So that's how we can kind of take objects and treat them in terms of their hierarchy and in terms of what they contain. So the null object reference is compatible with all reference types. Everybody comes down to a null if you want to, if you can assign the object type to null. The types higher up the type hierarchy are said to be wider or less specific. They're lower, or excuse me, they're narrow. Well, they're wider. They're less specific than the types lower down the hierarchy. So similarly, lower types are said to be narrowed or more specific. So widening conversions assign a subtype to a supertype. And it can be checked at compile time. No action is needed. Narrowing conditions or narrowing conversions kind of could cause a problem because you're converting a reference of a supertype into a reference of a subtype. Must be explicitly converted by using a cast operator, which is what I've been talking about, this cast concept, where we cast one object into another. And in terms of the types higher up in the type hierarchy are said to be wider. Oh wait, this is the same slide. Oh no, this is the widening to lowering, lowering to widening. It's the opposite way. Two types of conversions in terms of the widening conversion, assigning a subtype to the supertype, or narrowing conversion, converting a reference of a supertype to a subtype. So, lowering types are said to be narrower, more specific. So here we have our type conversion examples, explicit typecasting, and here's what I'm talking about here, where we're taking an object, and you can actually do this. You can just create a generic object. Every class is an object. Everything is inherited from objects. So here we've got a string. I'm going to say a string is equal to test. Object J1 is equal to object string. So we're typecasting the string to an object. We created a string object, and then we have object to a string, which is okay. We can't take a double. It's going to be narrow. It's going to be too narrow. So string is we can't. It won't fit essentially. So for a narrowing cast, it must be provided an unsafe, it's an unsafe cast if it's not going to fit. If it will fit, then it's just fine. So it's the same concept you see with typecasting in C and C++. And usually you lose, it works, but you lose precision. In Java, it just won't be allowed. You'll get an error. It won't, because it's not going to think. It's not going to narrow something down to the point where it's going to lose data. How can you take half an object, or half of a, something? It's not going to work. So. If the compiler can tell the narrowing cast is incorrect, then the compiler error will occur. If it can't tell it, there's no error. And then you have the possibility of a problem occurring at runtime. If the compiler can't tell, and then at runtime, it's going to give you another, and the cast is incorrect, you're going to have a class cast exception that's going to be thrown at runtime. Which means when you look at those little error messages you're going to get eventually, you're going to say, well, it compiled just fine, it ran just fine, but now I'm getting a class cast exception. Go back and look at what you're doing, and you're probably narrowing and you're making a mistake with the narrowing, and it can't all fit. So here we go. We have some more examples here. We have a test. So the student is a subclass of person. And we have a public class. This is going to be our driver program. We're going to create, and this is actually going to help you with the second assignment, which I'm going to go over after our short break, where we have an array of people that are going to be equal to 10 people. And we've put a block of code in here for static, if you remember that from last time, which is not the best way of doing it. So this example is just for illustrative purposes. This is just a block, running it like an old C program, essentially. So then we have a little loop, for I is equal to 0, I is less than 10, I plus plus, go through here and populate the array with I, for the P1 through whatever, 0 through 10, new students. So notice I didn't actually give this to, I just created new objects of students, and we have new person. And then out here, in terms of another implementation, we're going to cast it, and what we're doing is we're taking, what are we doing here, person, and we're calling them students, and we're trying to put a student into a person, and it doesn't fit. So we get an error message that says that person as a type doesn't match. So we're getting a type mismatch error / narrowing conversion, and it's causing a problem. So we've got an array of people, and we're putting students in one and person in the other. Yeah, 5. We're going half of them, and then we're switching them around, and they're not fitting because it's looking for a. I'm not doing this in the exact order that this is appearing, but we've got 2 different types of objects, and we have an array that's going to hold one type, but it's narrow. And so when we try to put the other type in there, it doesn't fit. Yeah, we're creating objects of students and people. But we've created an array of people, a person, and a person. A student is a specialization, and we're trying to stick a big thing into a small hole. It's not fitting because it's narrowing. It's a narrowing. It's the same object, but the problem is that array. The array's not big enough to hold it because we've defined the array of a person, and it can't fit a student. So. Type conversions. Here we go. Here's how we do it. And you're going to need this for, actually, you can use this in your Fahrenheit program. It's the instance of. So type testing. Because remember back in the comparison, which I did not do on assignment number 1 because we haven't covered this yet. And I wanted to have you do it. You can test, and here's another little example. If an object is an instance of a string, then it's casted to a string. If it's, and what we're looking at here is what's in red, this instance of operator. So you can test the object's actual class by using the instance of operator. So you're going to need this actually in assignment number 2 as well. And say, if you're an instance of this, then treat you like this. It's a safe way of doing a typecast. If you're not an instance, if you're a student and you're not an instance of person, we only have people that come here, but maybe we have animals, there's different types of animals that are also students, then if you're not, then we can tell who you are by saying, are you an instance of this? No. Okay, so you're not a person, you're a dog or a cat or something. All right. The school's for everybody. So, and here's an example. No, actually, there's not an example. I'm going to switch to another concept called the abstract classes. So a little mention about abstract classes as an example. So abstract classes and methods. The class itself, some methods are only declared, but the concrete implementations are saved for further future implementations. So no concrete implementations are provided. They need to be implemented by the extending classes. So another comment associated with inheritance. We have a person, and the person can be an employee or the person can be a student. We have an abstract class person, and we have a string method called getDescription. Down here we have to put in a getDescription. If we take the class student and extend person, we actually have to implement it. If we don't implement it, we get an error message. And then we have the class employee that extends person. We have to put, everyone has a get description. You can probably maybe see why. Because it knows if it's abstract, we know we're kind of, and I don't want to use the word template, but we're setting a template structure that we want to implement, and we want to make sure that every one of the inherited classes from that abstract class is going to implement something because we haven't implemented it yet. And if the method's there, it can be run. So if this can be run, it's going to find it from the inherited class, and it's going to run the method body that's implemented in the specialized inheritance class. And this is the concept of what they're referring to in terms of specialization. So when you actually implement it, you're making it specific for an employee versus a student. As an example, if it was a get description in here, we're going to have different things. An employee is going to be described differently than a student. Why put it here? So if we don't want to put it here, but we want to know we're going to get a get description, we see this with toStrings, we see this with all sorts of different like generic type of methods, then it's just basically saving you time and energy. It says, well, we want to put it here, but we can't really make any generic description of a get description right now. So instead, we're going to let the employee and the student do their own get, and we want to make sure that they do that because we want that functionality. So we make it abstract so that it has to be implemented. So each method which has no implementation in the abstract class must be declared abstract. And if you have abstract methods in a class, the class has to be abstract. So any class with any abstract methods must be declared abstract as well. Then you start seeing abstract, public abstract, class, blah, 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 and then everyone starts putting abstract on everything. And they go, oh no, so only use abstract when you need to. When you extend an abstract class, two situations occur. Leave one or more of the abstract methods. Leave some or all of the abstract methods to be still undefined. Just create them but leave them empty, because it has to be there. Then the subclass must be declared as abstract as well. So now we start building abstract classes off of abstract classes. And define concrete implementations of all of the inherited abstract methods, then the subclass doesn't have to be abstract anymore. So if you leave something, this is where people just start going, oh, I get an error message because there was an abstract method and I didn't put it in there. It's in there, but it's not implemented yet. It's not there yet. It's not there yet. It's abstract to the point where it's finished. When it's finished, it doesn't have to be abstract anymore. It's not abstract anymore. It's implemented and it's done. So abstract just basically tells you that there's something in there that's not implemented. There's methods in that class that are not implemented yet. This is what it's telling you. It's supposed to be telling you. An object of an abstract class cannot be created. You cannot create objects of abstract classes. So, which means you can't go out and make an instance of that class. It doesn't work. It's not implemented. It's not done yet. Abstract is kind of, think of it more of along the lines of work in progress. Not implemented yet. Not ready for production. Not ready for life. So it's Frankenstein. Until you finish him, and you turn the power on, and then you can make an object of him. And note that declaring object variables of an abstract class is still allowed. You can create variables. You just can't create new objects. But such variable can only refer to the object of a non-abstract class. So, protected members, as we've seen so far, it allows you to, this is the formal kind of summary about the protected concept of the access modifier, to allow subclass methods to access as superclasses fields defined as protected, but be cautious. Making methods protected makes more sense if the subclass can be trusted to use the method correctly, but other classes can't. Other classes can't make it private. Otherwise, you open up the door. And in fact, a lot of people just make everything protected if they think it's going to be inherited. And they don't use private anymore. But can you trust the class? All the classes? So you're just essentially making it public, essentially, to all the classes. What protected really means. Precisely, a protected method is accessible within the class itself, obviously, within code in the same package. Good. And it also can be accessed from a class through object references. That can be at least one, the same class type. References of the class's type or one of its subclasses. It really does open up the door and make it public to everything. So, and I'm not going to go through this example because we've seen protected being used already. So, object. Let's go back to the beginning of time. Everyone comes from object. The ultimate subclass, and this is what I'm saying. You can do things on the object. So a person who's an employee, you can take the employee, treat them like a person, but you can go back to object. You can pass object back and forth, you can compare objects, you can, and here's some other things you can do with objects, which you're going to do probably in the temperature class. Take the object and compare it to another object. Is it equal? No, this temperature is storing something, and that's storing, oh no, actually they will be equal because they're all temperatures. If you do it that way. If you take an object and make it equal to another object, it's going to always be equal. So object class is the ultimate ancestor. Every class in Java comes from the object class without mention. You don't have to say anything to it at all. Utility methods for the object class, and here we go. Equals returns whether two object references have the same value. So you can actually see from object, you can inherit this. You can run this method equals on two temperatures to see if they're both Celsius. One of them might not be Celsius. One of them might be Fahrenheit. And you're checking to see if the data member of those two objects are equal. So equals actually will come in handy for that. Hashcode returns the hashcode of the object, which is derived from the object's memory. Never have a need for that. Equals, the equal should return the identical hashcodes. Clone, return a clone of the object. Oh, we can start cloning objects now. Well, we have real life object orientation. We have all these instances of objects, which are unique instances. You can clone an instance. Well, you can't do that in the real world. Get class returns the class expression of the object's class, which is the class object itself. Finalize the object during garbage collection, takes it away. ToString returns a string representation of the object. Takes the object and prints it out in a readable format that's not object code. So here's some design hints for inheritance, some summary stuff. Place common operations and fields in the superclass. Common stuff that's going to be used by everybody, so you don't have to reinvent it every time. Try not to use protected fields. You want to make them private. It's the same reason why you want to make them private in a regular class. Use inheritance to model an is-a relationship. So a student is a person, is a object. So you want to model it by, because then what ends up happening is you get like the recreational vehicle class, and that has, well actually that would work. We have the boat class, let's say, and in the boat class we have cars, instead of different types of boats, and then if you don't use the is a relationship logic, then you have some really weird inheritance. You got some stuff that doesn't make sense. Don't use inheritance unless an inherited method makes sense. So trying to limit, otherwise it gets kind of confusing. Don't change the expected behavior when you override a method. If it's to print something, it should still print something instead of getting something. Or use polymorphism. Not type information. So you don't want to get the type, you want to get the, the polymorphic stuff. And let's forget that little example on the bottom. Alright, so I think it's time for it's actually almost time for a lunch break, I guess. I've been going for 2 hours. Long-winded today. Do we want lunch? It's a 12:05. Do you want us for like a half hour? Take one break? 45? Half an hour? Very good. Unless people want longer. Use this as your lunch, because what I'm going to do when I come back is I'm just going to go bang, bang, bang all the way through and we'll get out early. No? Unless people want a longer break. Speak now or forever hold your peace. We'll come back at 12:30. How's that? Half hour? 12:45. Perfect. That's why I want people to talk up. Bring back. We can eat in the classroom if you want. I'm not in a hurry. I'm just thinking you guys probably want to spend your day doing something else. I don't know. Who knows? We'll see. So I'll see you at 12:45.